Hi everyone, my name is Subhasis. In continuation to the previous session, which was on how you build a horizontally scalable indexer for Elasticsearch, which is also multi-tenanted. So it has to be tenant aware. At the same time, it has to be horizontally scalable. What it means is the indexer component that we'll build for Elasticsearch, I should be able to run in two different modes. The default one is I can run it as a simple client, Java client, which will take your indexing request uh, and then it will pass those requests to Elasticsearch. The moment indexing is done, it will come out of the client will exit, right? That's the client mode of operation. It can also operate as a service, which means it will be continuously running. It's like an event loop. When it is running, right, that indexer component which is running in service mode now. Imagine you have so many instances of that same indexer, all are running in the service mode. When all of them are running in service mode, they should be able to talk to each other via some uh, distributed directory service, like the state of each of these indexer, right, has to be maintained in some directory service, and one of the service will be electing itself as the leader, and rest of the instances of that indexer will either they will be running in the same system or different system. It doesn't matter. The coordination will happen via the directory service, right? So the directory service that we'll be using today is ZooKeeper, and there this indexer component will be supporting, just as an example for a real-time indexing scenario, wherein the application, the primary application is sending events to, let's say, a ticketing application, let's say a school management, application, and you are creating new students, right, for a particular school. So that's an event within the application. And that event will be passed as a message to the message bus, which in this case, for our example, would be Kafka. And that, that when the application is creating a new student, it will obviously persist in the database, right? That is your, source of truth. And it will also pass a part of the message to the message bus. Now, the indexer that we'll be building, that will subscribe to, right, each of those instances of the indexer, all are running in service mode. They are going to subscribe to the message bus, right? Now, do all of them need to subscribe, or maybe the master can subscribe and get the work? It is like, okay, I'm the new master, I'm the new leader in this cluster. I'll get the work for you, and then I'll assign to the individual workers, right? So the same concept will be mimicked in this particular indexer design. Now, when the master node has got the work from the Kafka and then it has created those as a task in ZooKeeper. We'll be creating different kind of nodes in ZooKeeper. One would be, let's say, all the instances of the indexer. They will be joining as worker, or they will have different process ID, right? And then the first process which has joined this uh, cluster as a service, that will be elected as a master. I'll show you that logic, how to elect that as a master or the leader. Once one of the indexer has designated itself as the leader, that will have the subscription to the Kafka. It will get the work, and then it will again create task nodes in the ZooKeeper, and it will look at, okay, how many workers do we have? How do I kind of distribute this work? So there also you can put a lot of intelligence. You want to put round robin, you want to put some more into, like the load balancer does. So the orchestration of, okay, this task I'll allocate to this particular worker, this next task I'll allocate to another worker based on how many workers I have at that point. Otherwise, if it is just one worker, then I'll pass everything to the worker. You can also, because you are the one who is designing this whole thing, so you can also say my master can work. Okay, because let's say I'm running it my system, I'll just run only one instance of the indexer in service mode, and in that case the leader or the master can also work, right? There is no other instance of the indexer who can actually take the indexing request and pass them to Elasticsearch for indexing, right? So you can configure it in such a way that the master can also work, right? All right, so enough said. Let's get into the code. All right, so this is the same repository that you have already seen in the previous video as well. All right, and then the next thing would be the same code that I'm going to run it in Eclipse. Okay. Now, before I pull the code into Eclipse and run it, I'll have to run some of my components. Right? I've talked about Elasticsearch, I've talked about Kafka, ZooKeeper, and also I'll be using Kibana for some of the operation on the index or searching through some data, right? All those things. Anyways, so this is the indexer project here. You can see. All right. Now let's move to component by component. I'll first run the ZooKeeper. ZooKeeper is started. I'll use the same console for my ZooKeeper client. Okay, and I can say, okay, show me what all directories are present in the root of it /o. Okay, you don't see any other directory there. So they're basically node in ZooKeeper. Okay, so this one is, I'll keep this window aside for now. I don't need this. Then once I've run ZooKeeper, I can run Kafka as well, because it will rely on that ZooKeeper. Okay, so Kafka comes with its own bundle of ZooKeeper, but in this case we are using localhost 2181, is same host and same port, so it will connect to. If I start Kafka now, it will connect to that same ZooKeeper, which will be using for our own indexer as well, right? So Kafka and our application both will be using the same ZooKeeper, right? All right, so let me start the Kafka. Okay, let's just ensure it is started properly. Looks like yes. Next, I'll be starting Elasticsearch, because Kibana would be dependent on it, right? Next, I'll be starting Kibana. Okay, let us start, and then we're having two different terminals. I'll talk about them very soon. All right, Kibana is up as well. We can verify quickly if we have got it up and running. There you go. Okay, the indexes that we are interested in is this. Let's see if it already exists. Yes. Let me just let me delete it. So we'll start from the beginning of it. All right, and then let's go to the code. So we have all the components that our indexer is dependent on. All of them are running. Next, what we are going to do is look at this flow step by step. So I will not require some of this window. Let me clean it up quickly. Okay. So the starting point is index client, and as we have discussed, so it can run it both client and service mode. First two are not saying service equals to true or false, so they are all going to run it in client mode. OP is operation type, which is either you are doing a full index, like you have the tables that you're going to scan through from your relational database. You are going to scan it entirely, those tables, and you're going to get the entire data that is existing in those tables, right? That you want to index in Elastic. Incremental is okay. You have some checkpoint, like say I'll look into Elasticsearch. What is the last updated date on which basically date time till which I have my documents indexed in Elastic. Beyond that point, what is the incremental data that has been either inserted newly or updated or deleted, right? You take all of them as incremental records, and then you can index in incremental mode. In that case, you're not going to scan through the complete table, but you want to scan only the part of the data based on what is the new data that has come, right? Till until the last point where you have already indexed in Elasticsearch. And the third mode is, of course, that applies. In this case, it will be right now the code that is implemented here. It is only for selective or full near real-time index. Okay, so even if you don't pass, it will not matter. By default, it is going to work only in the selective mode or real-time indexing mode. And then minus C is common. Okay, sorry. Minus C is like, okay, so what is my config directory? So you can see all those config, right? So if I pass this config directory, it can relatively scan any of the other configuration that is required. So it has got configuration for database, the RDBMS from where you want to read this. That is your source of truth. This is Elasticsearch configuration, then indexer, like what all indexes you need to actually for which you need to build, push the data into Elastic, how you want to query the RDBMS, what is the document type, your primary key or ID key, modified date. This is useful for incremental indexing. Any custom mapping, let's say, on the database side, it is like one single field, comma separated, right? 1, 2, 3. Here you want to create a custom map of, let's say, array, or you want to transform that data, fan out that data. You want to do something. So that would be coming in the custom map. So you can create custom class by extending certain contract like interface, and then you can provide that class implementation here. Refer the class, fully qualified class name. Okay, and then you can define on which attribute you're going to have the custom. So let's not focus on this today. Maybe we can have one session on that, how we can provide custom mapping for based on your business need. Keep index creation. Okay, ignore that as well. Then you have log status ignore. Mapping is like for different document type, right? Index. You want to define the mapping of it, the data type, whether it is analyzed or not analyzed. Yeah, for all the fields. Then you can see that this index, if I index config, if I show student ID, name, age, roll number, you can see all of them here. Student ID, name, age, roll number, and based on their data type, whatever is applicable type in Elastic, that's what I will provide here. Okay, I'll quickly rush through message bus. Important, like Kafka, how you are configuring, what is the queue from which you are going to read the data, where Kafka is hosted, localhost 9092. That's where it is running, and you're listening for any request. Search template, ignore. All tenants, right? As I said, it's multi-tenant enable, right? So you can define as many tenant as you have. This is for tenant 1. Likewise, you can for tenant 2. Okay, and what is it, database name, blah blah blah. And then ZooKeeper config. So this is what I'm going to focus more today. Now the databases, the ZooKeeper will have for every time you run an instance of the Elasticsearch indexer, you should provide a different node ID. So this is similar to your broker ID or Kafka manages with ZooKeeper, right? In your cluster, if you have multiple brokers, every broker will have a unique ID, right? So exactly same concept. Node ID is the indexer ID. If I run another instance, I'll provide like 2, 3, whatever makes sense to you, but try to use the unique ID so that they don't conflict. Host is the ZooKeeper host and port. Path election, again, I'll go in details, like when you're running multiple indexes, indexer component, they will all have to register themselves, right, for election, leader election or master election. And that's the ZooKeeper path or node in which we'll be creating those, the nodes for individual indexer processes. Process node prefix, Again, this you can manipulate like, okay, P underscore P to signify this is my indexer process. Master can work. I spoke about this. So right now it is configured as false. That means master can only do master specific role, not the worker specific role. If you say master can work is true, then it can also work as a worker. That's about most of the configuration, and then log for your logging. Let's go back to index client, and here we will run this in service mode. Okay, for that I've already configured, and if you look at this, run configuration, go to arguments, and before that I will show an environment variable that I've set to the path of this project, right? To that, if I edit and show you can see. So the code that is running from within Eclipse, it is the root path of that. And after this, it will resolve the config folder. How? That is here in the admin. So I'll say minus P, that is my config directory, is Elasticsearch util home. That's the environment variable we just saw, and then / config. After that, the relative path of individual config folder, it will resolve. It has that intelligence. And then minus service true. That means I want to run it in service mode, right? If I take it out, it will just do a full index. I can put minus OP as full. There are some default choices which are already codified. So otherwise it will go based on the operation type that you have mentioned. You can see it got over 338 records to be indexed, and my batch size is 100. That is again a configuration. You can see it here, index config, batch size, batch count of 100. So at a time it will pass 100. So you're able to throttle also. At a time it will pass only 100 records for indexing within Elasticsearch. Okay, and then what was there? So total batches is 4 because it's 100, 100, 100, and then 38 for the last batch, right? That's how it is able to manage in 4 batches. So that is about running it in client mode, but today we're going to run it in service mode, right? And how you want to run it in distributed mode also, right? That's the whole thing. So let's say minus service true. Before I run this, I'll show you the state of ZooKeeper. Okay. Where am I? This is the one. So if I say ls slash, okay, I'm looking for a node called next level for my indexer component. That is the root node. So it is not created yet. You can see that means, so far I have not run any of my indexer component in service mode, right? Now I'm running it. It says few things. Process with ID 1 has started. Process 1, I am the new leader. I'm the new master, right? So what is happening, right? Now if I do ls slash, you can see next level has been created. And you also might be recalling ZooKeeper config I mentioned. What is the path for election? So if I say ls, you can see the first process, which I have just run in service mode, that has registered as a first node. And because it is the only node, the leader election, obviously it wins, and then it is saying I'm the new leader. Now, the fun is I want to run it in horizontally scalable. So that means I can bring up more and more indexer component, right? How do I do that? So first thing first, so now the path I'm in is, so I've copied from what I've been running in Eclipse. I've copied the target and config folder only, nothing else. Target will have my Java binary, the jar binaries that I'm going to run. And then config will have all the config folders. Now, this is a separate indexer instance. So I can manipulate my config however I want. So the part that I've manipulated is, in the config /zookeeper config, I have kept node ID as 2. The third instance will have node ID as 3. And the root path of this folder, the application folder, the indexer folder is also different. I'll say this is my Elasticsearch util copy. Same way, I'll say for the next indexer component, I'll say indexer 3 is my Elasticsearch util form. Okay, I'm done. And then I'm going to do what I'm going to do is I don't have the command. It's okay. The main class. Okay. After this, I can copy the parameters that the arguments I'm passing here. Instead of typing it again, I'll say run configurations and then copy rest of this thing. So minus OP does not matter here. As I said, it is always, I have coded, right now it is coded only to do selective or real-time indexing. So rest of the things doesn't matter right now. Here I'll say -3. This is my Elasticsearch util home, which is the current directory. And then -service2. Okay. Oops. Oh, I picked the wrong jar. 1 second. I'll pick the one which has all the dependencies also. I would say with, right? Dash dot this 1.0 dash dependency. Yeah, there you go. And for the third instance, I'll explain what is really happening. Okay. So the second instance of the indexer says process ID 2 has started. Setting watch on node with path something. Third instance is process ID with 3 has started. Setting watch on node with path and 0, 1. And here it is 0, 0. Let's go back to the ZooKeeper. Let me move it over here. Let's see what is happening. So you can see the first process which I ran from here, which already elected as a leader. That is this. Second indexer which I ran here, that is or this one. Third indexer instance is this one. Now, so the first one said I'm the new leader. How does that happen? Let me go back to the code now. So when I'm running it in service mode, okay, it says run as service, run indexer as service, and then it creates a thread pool with one thread, and then all of the operation that I'll be doing in ZooKeeper, all the callbacks and everything that will be happening in the separate thread, right? So your main thread is not blocked for any of the ZooKeeper callback handling, right? So that is happening here, and then I'll create the process node, which is basically a callable. It implements the callable interface. Okay, and then what else? I say that is my node ID. Okay, node ID, you saw already the configuration, and then ZooKeeper URL. So I'm passing these two things into the process node. I'm saying, status.get. So you're actually waiting for that, thread synchronization. Now we go to process node, which is a call runnable, and then the entry point obviously is the constructor and the run method, right? So let's go to the run method first. This is the run method. It says process with ID has started. Let's map it. Process with ID 1 has started. That is your node ID that you passed. Then it says root node path equals to election root node that you saw here. That is election root node, this one. So it is looking for that path and it is creating actually, right? And next it is what it is doing. Process not prefix. So the individual process, right? Which is what we saw here. This one got created next. Okay, and then it will say attempt for leader position. Here, it will say, okay, get all the children under this particular node, like election, this particular node, get all the, so it will get initially when you started the first instance from here within Eclipse, that was the process, right? So it will get only one of them, and sort will just you're sorting only one node, so that's the same node. Then you say, okay, get me my position, the current process node position in that overall, sorted list of all the process node that exists. And it says, okay, if index equals 0, that means I'm the only node that exists there. Okay, then I say, okay, I'm the one second, index equals 0. I'm the leader. And so perform. So it says process, I'm the new leader. That's what you can see here. And then it says, ZooKeeper service bootstrap as leader and the perform leader role. So in the leader role, you can define, right? So in this case, what I've done is I've subscribed as a consumer to Kafka in this case, because that's what I've configured in the message bus, Kafka. And here it will subscribe to the Kafka topic as a consumer. And okay, that's it. And yeah, that you can go there and look at it. That's how it is doing. So let's do that. Subscribe for indexing request. And here you are running it in while loop. That's the event loop that I said. So it is running in while loop and it is waiting for any new message from the Kafka. Once it gets the new message, it says invoke near real-time indexing. So what really happens there, right? So the leader is going to get the message from the Kafka topic, and then it will do something, right? What is that it is going to do? Let's come back. I'm coming back to this. So it will do some leader role. Okay, it has subscribed. It will get the message and how it is creating those tasks as a leader and then assigning to the individual worker. What happens if you're not the leader? So that is uh, the second instance and third instance. They are not leader, right? So what happened to them? So they got into this block because their index was not 0. They were not the first node which got created under that election path. So it found, okay, uh, from my index position, what is the previous node's position? I mean, what is the previous node before me, right? So for second indexer, which is here, the previous index, previous process is this one. So it is setting a watcher. Watcher is nothing but you are observing for any change happening to this particular node. ZooKeeper works, purely on event model. Now you can subscribe to, as a watcher, you can subscribe to those nodes. Any change that is happening to that node, you will be notified, and you can handle that, right? That is again based on your business logic. In this case, what is my business logic? I'm watching on that node, and if anything happens to that node, right? In this case, okay, let's say that master gets killed for whatever reason, right? So you'll have to, the cluster has to have a leader. So who is the new leader? So leader selection has to happen. For that process, you are going to watch on the previous node that got created before you. Similarly, for the third indexer, which is here, the previous node that was created is this one, right? So it is watching on the previous node. If this node gets killed, then it will get itself elected as a leader. Okay. And if you are not a leader, then you are going to perform worker role. So what is the worker role? That is also defined here, right? So that flow coming back. Yeah, this is the worker role. This is the definition of it. You have to register as worker, uh, basically creating another node in the and the specific path of Elastic. Let's look at that also. Oh, not this is not the ZooKeeper client. This is the one. So I'll say, okay, you can see workers, right? And you say uh, indexer slash workers. right now worker 2 and 3. 2 is nothing but their node ID, right? 2 and 3 they got created and they have registered as a worker. And also for tasks, you can see if there are any tasks right now, it will not have anything because until I pass those messages to the Kafka, task will not get created. Task node will not get created. What are the other node status? So this will have, if you have taken a real-time, indexing task, and then you have to register the status, whether it got passed, whether it got picked up for indexing, whether it got successfully run or it failed. If it failed, then again master will again put that for another node to index. So you can handle those kind of uh, error situation by these are basically how you want to you know make your application more and more robust to failures. So those are something that, and then task assignment is in the assign. Okay, so that's mostly it. Perform leader role, we have spoken about it, right? And then what else is important? Let's see. Create task, right? Just look at it, use this. Let's see, handle delivery. That means you have to this implementation is for RabbitMQ, but otherwise just for understanding purpose, right? So what it is doing, it is creating a task node under this particular path. Okay, as task dash, and then you'll yeah, as a task node, and then it will have it. You are creating as a persistent sequential, so it will have some random ID attached to this task dash, and then there will be some random ID. So ZooKeeper creates different kind of node, persistent, sequential, persistent, and you can understand what would be applicable to your use case. So let's say this process node, right? Process node that we saw. If I kill a particular indexer instance, then you will see this node getting disappeared from ZooKeeper. So the moment the client, as a ZooKeeper client, you have disconnected the session with ZooKeeper service. That means the specific node type that you have created, right? Whether it will be persisted in ZooKeeper or not, it matters. Now the process node that we have created earlier, let's see the difference. So when I'm electing as a, when I'm creating myself as a node, let's go back to process node. And here, perform, you're creating the node here, right? So one second, sorry, I have to go back to the run method one more time. Just okay. So the second step, I'm creating the node, and here what I'm saying, ephemeral, or ephemeral sequential. There is some variable spelling issue. Don't worry much about it. It's basically ephemeral. That is the spelling. And so that also you can control. So in this case, we are probably saying false, if I'm not wrong. Create node one more time. What is false? Ephemeral is true. So ephemeral is true means the node that you have created in ZooKeeper, it will not exist once the session is gone. Okay, if it is not ephemeral, then it will persist. So if I kill a worker, the worker folder worker node that you saw, that will continue to remain here. Again, I have not really used the worker nodes for any of the functionalities other than task assignment, but this one I have used for the election process, right? Leader election. So now, I think that's pretty much it, right? So you subscribe for the event, and then as and when you get the message from the message bus, you are going to create task node and assign it to your different worker. Worker will pick that task and do the real-time indexing, right? That's pretty much it. Okay. Yeah, there are a lot of code because I have put a lot of watcher on different kind of events. I have put watcher on different kind of nodes to get those events, and then on that event, on that callback, I'll have my implementation, right? Different kind of implementation. So this one is getting all the task list, and then it will assign to individual worker, assign to worker. You can see, okay, and then task data callback. Maybe this is the one that is actually indexing it. So it is taking out the JSON message, and first of all, it will read the data because when you pass, this is the message that will be coming from your message bus. So it has only few metadata to get the ID value and all, and based on the ID, you go to the database, which is your source of truth. That is converted to JSON object, and then you say, okay, on this JSON object, you do the near real-time indexing. And once you do, just update the status, and also delete the worker because it's already done. So you can, make it a little more robust. Here it is not really. So you can improve on the this kind of code, but you get the fundamental, right? Invoke near real-time indexing. So based on the type of event, like whether it is a create event, whether it is an update event, whether it is a delete event, you perform different kind of thing here, right? On Elastic. So yeah, pretty much it. So if you have any questions, please let me know in the comments, right? Other things that I want to quickly show before I wrap up is, let's say I kill one of the index the process, right? It was a worker. Did anything happen to any of my other processes? No, because a worker got killed, right? Only change that you will see is like on this particular path that 001 is gone, right? That is the node type ephemeral. So the second thing that I want to show is, okay, let's bring back this guy. Now it is watching on 002 because the process ID got changed, right? So now it is no more the second one. It has become the third one, and it is watching on the previous node, which is 002, right? So its turn will come as a leader after this guy is gone, right? And okay, you can see setting watch on node. What happened, right? Because the intermediate one, which was 001, that got killed. Now, as a worker, also I'm watching on this particular node. When that node got killed, I'll again check. Am I the index 0 position? Am I the leader? No. Index, the previous one is this one. So I'll put a watch on this. Now, the moment this leader exists, this guy will get its turn to be elected as a leader. Let's see that. So I'll kill this deliberately. This guy is gone. In the ZooKeeper, quickly, we'll see 0 is gone. Now 2 should be the index, right, as the leader. And that's what has happened. You see, I am the new leader. Okay. And that means this guy is watching on 2. This guy is, if I bring this guy back as another indexer, this guy is not going to be a leader, right? This is going to be worker process. And it says I'm watching this guy, 3, right? And this guy is watching 2, which is nothing but this. So this time if 2 gets killed, which one will get its turn? This will get done. You'll see now the leader election will happen and see I'm the new leader. So this has become the new leader. With this, I'll stop and I'll look for any of your comment, any feedback, any next session that you are looking for on this. Thank you for watching.